Company wants to reduce embedding generation costs for their vector search system. Their Titan embeddings use the default high dimensionality. What is the most cost-effective optimization? A. Reduce the number of documents indexed by removing older content. B. Switch to a different embedding model from a third-party provider. C. Reconfigure the Titan embedding model to use lower dimensionality that fits the domain requirements. D. Increase chunk sizes to reduce the total number of embeddings generated. The correct answer is C. This question is not about retrieval quality first. It's clearly about cost optimization. The key clues are reduce embedding generation costs, Titan embeddings, default high dimensionality. If you know Titan text embeddings version 2, you should immediately recall one important feature: configurable output dimensions. Titan does not force you to use the highest dimension. You can choose lower dimensions that still meet your domain's retrieval needs. Lower dimension means smaller vectors, less storage in your vector database, lower memory usage, faster similarity search, and lower overall cost. For many focus domains, 384 or 512 dimensions perform just as well as 1024 without the extra expense. That is exactly what option C describes. You are optimizing cost without changing models, without degrading the system, and without throwing away data. That is why C is the correct answer. Option A is incorrect because it suggests removing older content. That does not reduce cost, but it does so by reducing system value. The question asks for optimization, not degradation. Removing data is almost never the best architectural answer. Option B suggests switching to a third-party embedding model. That introduces migration effort, re-embedding cost, and operational complexity. The exam strongly prefers native optimization before architectural replacement. Option D is incorrect because it suggests increasing chunk sizes. This reduces embedding count, but at the cost of retrieval precision. Larger chunks dilute semantic meaning and hurt search quality. This is a quality trade-off, not clean optimization. For embedding cost optimization on the AWS exam, do not delete data, do not swap models, tune dimensionality first. The correct answer is C. The team needs to validate that their RAG system retrieves relevant passages before each deployment. They have dataset of queries with known ideal retrieval results. Which evaluation approach is most appropriate? Option A, run Bedrock model evaluations in text generation mode to score overall response quality. Option B, configure CloudWatch metrics on OpenSearch query latency as a proxy for retrieval quality. C, deploy a canary that replays test queries and compares response hashes to expect values. D, use Bedrock RAG evaluation jobs in retrieve-only mode to measure context relevance and coverage. The correct answer is D. This question is extremely precise. The team wants to validate retrieval, not generation, and they already have known ideal retrieval results. That immediately tells you two things. End-to-end response quality is not enough, and you must isolate the retrieval layer. This is exactly what retrieval-only mode in Bedrock RAG evaluations is designed for. Retrieve-only evaluation measures whether retrieved passages are relevant, checks whether coverage is sufficient, and separates retrieval quality from generation quality. This is critical because a strong foundation model can mask poor retrieval by generating plausible answers anyway. Option D directly evaluates the thing the question is asking about, using the data set the team already has. That is why D is the correct answer. Option A is incorrect because it evaluates text generation quality that blends retrieval and generation together. You lose visibility into whether retrieval is actually working. Option B measures latency, not relevance. Fast, wrong answers are still wrong. Latency is an operational metric, not a quality metric. Option C compares response hashes. Generative systems do not produce deterministic text. Semantic correctness cannot be validated with string hashes. For RAG validation on the AWS exam, if the quality says validate retrieval, use retrieval-only evaluation. The correct answer is D. A company wants to use Bedrock, Amazon Bedrock, to process scanned PDFs and images for a document understanding application. Which service should they use for document pre-processing before foundation model consumption? A, Amazon TextTrack to OCR documents and Comprehend to extract entities. Option B, Amazon Recognition to extract text from images and PDFs. C, Amazon Bedrock data automation to convert documents into structured JSON and HTML outputs. Or D, AWS Glue Data Brew to transform document formats. The correct answer is C. This is the modern Bedrock question, and the exams expects you to know the newer services. The key phrases are document understanding and before foundation model consumption. This is not just OCR. This is semantic document understanding. Amazon Bedrock data automation is purpose-built for this exact scenario. It understands document layout, exacts structured data, preserves relationships between elements, outputs clean JSON and HTML, and integrates directly into Bedrock workflows. It replaces complex multi-service pipelines with a single managed capability. That's why C is the correct answer. The other answers are incorrect because option A uses TextTrack and Comprehend. This requires orchestration, transformation logic, and still lacks deep structural understanding. Option B uses recognition. Recognition is for images and video analysis, not document processing pipeline. And D uses Glue Data Brew. Data Brew operates on already structured data. It cannot extract meaning from scanned documents. For document pre-processing in Bedrock-based GenAI systems, OCR extracts text. Data automation understands documents. The correct answer is C. Company needs their foundation model application to automatically recover when Bedrock experiences regional service disruptions. They want to keep traffic within North America. Which approach provides the best resiliency? A, cover an Amazon Bedrock cross-region inference profile limited to North America regions. Use AWS Global Accelerator to route requests to the healthiest regional endpoint. Deploy duplicate application stacks in multiple regions with Route 53 health checks. D, implement retry logic with exponential backoff in the application code. The correct answer is A. This is a resiliency question, but notice where the resiliency is supposed to live. The application wants to recover automatically. It wants to handle Bedrock regional disruptions, and it wants to keep traffic within North America. That immediately tells you this should be solved at the Bedrock service layer, not in your infrastructure or application code. Amazon Bedrock cross-region inference profiles do this exactly. They automatically route inference requests across multiple regions behind the scenes. You do not manage endpoints. You do not deploy duplicate stacks. You do not write failover logic. And importantly, for this question, you can select North America. That combination of automatic failover, zero infrastructure duplication, and geographic control is what the question is asking for. That is why A is the correct answer. Let's talk about why the other answers are incorrect. Option B uses Global Accelerator. Global Accelerator works with your own regional endpoints. Bedrock is a fully managed service, so this would require extra infrastructure that the question does not ask for. Option C deploys duplicate stacks. That adds cost, operational overhead, and complexity. The exam strongly prefers managed resiliency when it exists. Option D is incorrect because it adds retry logic. Retries help with transient and errors, not regional outages. If the service is down in a region, retrials will keep failing. For Bedrock resiliency on the AWS exam, if the service supports cross-region inference, use it. The correct answer is A. Company security team requires that different departments can only access specific Bedrock models and knowledge bases based on their IAM rules. Which approach best implements this requirement? Option A, use AWS organizations SCPs to restrict Bedrock access at the account level. Option B, use IAM Identity Center with permission sets that map department groups to IAM roles with least privileged Bedrock policies. C, create separate AWS accounts for each department and deploy Bedrock resources in each account. D, implement authorization logic in the application code that checks user department before calling Bedrock. The correct answer is B. This is a classic enterprise access control question. The requirement is department level access. The control must be based on IAM roles, and it must apply directly to Bedrock models and knowledge bases. That immediately rules out any application-only controls. IAM Identity Center is designed for this exact scenario. It allows you to map corporate identity groups, like departments, to permission sets. Those permission sets attach least privilege IAM policies that specify which Bedrock models can be invoked, which knowledge bases can be accessed. And those permissions are enforced by AWS itself, regardless of how the user accesses the service. This is why B is the correct answer. The other answers are incorrect because option A uses SCPs. SCPs apply to entire accounts. They are too coarse-grained to control individual users or departments. Option C creates separate accounts. That massively increases complexity and cost. IAM already solves this problem cleanly. Option D uses application-level authorization. That can be bypassed if users access Bedrock directly. Security controls must live at the IAM layer. For Bedrock access control, use IAM, not application logic. Correct answer is B. Company stores conversation history for their Bedrock chat application. Over long conversations, the context window fills up and responses slow down. Which approach best optimizes for both performance and context retention? Option A, store conversation history in DynamoDB and retrieve only when the user asks about previous topics. Option B, summarize older conversation turns and only include the summary plus recent messages in the context. Option C, truncate conversation history to the most recent end messages before each request. Option D, switch to a model with a larger context window. The correct answer is option B. This is a context management question, and the key phrase is both performance and context retention. That means you cannot just delete history, and you cannot just keep everything forever. The best practice here is conversation summarization. You periodically compress older conversation that preserves key facts, user preferences, and established context. You keep the summary plus the most recent verbatim turns. This dramatically reduces token count while preserving meaning. That is exactly what option B describes, and that's why B is the correct answer. Let's look at why the other answers are incorrect. Option A retrieves history only when asked. That breaks conversational continuity. The assistant loses implicit context. Option C truncates history. This throws away important information and causes the model to forget earlier facts. Option D increases the context window. Larger context windows cost more and still have limits. This delays the problem instead of solving it. For long conversations, summarize old text, don't just delete it. The correct answer is B. The team wants to collect user feedback on their Bedrock-powered assistant to improve prompt engineering. Low-rated responses should be sent to subject matter experts for detailed annotation. Which approach is most appropriate? Option A, add a thumbs up or thumbs down widget that logs ratings to CloudWatch logs for weekly manual review. Option B, use CloudWatch synthetics to automatically test response quality. Option C, capture ratings via API gateway and Lambda, store in DynamoDB, and route low-rated responses to Amazon A2I for human review. Option D, enable Bedrock model invocation logging and scan logs for negative sentiment. This question is about building a feedback loop, not just collecting ratings. User ratings tell you what is wrong. Subject matter experts tell you why it's wrong. Amazon A2I is purposely built for routing items that require human judgment to reviewers. In this architecture, user ratings are captured via API. Full context is stored in DynamoDB. Low-rated responses trigger A2I review tasks. Experts provide structured annotations. That creates actionable data for prompt engineering. That is why answer C is the correct answer. Option A is incorrect because it does not scale and lack structured annotation. Option B is incorrect because it tests availability, not subjective quality. Option D is incorrect because it analyzes model output sentiment, not user satisfaction. For GenAI improvement workflows, use rating to trigger A2I. Experts close the loop, and the correct answer is C.